What's going on, guys? My name is Hussein, and let's just jump into the software news. We have some spicy, a little bit old news. Some of you actually sent me this article, and I gotta credit to you. I got your name. Kashif Minhaj. Thank you so much for sending me this article. So, guys, microservices. We talked about them in this channel. They're beautiful architecture. We talked about their pros. We also talked about their cons, the bad thing about them, and how people are just jumping into this train like there's no tomorrow, and how bad this is. We need to stop it. We need to stop the microservices wreckage train. And then Kalish Nad, hope I pronounce your name right, nailed this article. Let me repeat this. He nailed this article. It's a beautiful, well written, and I agree with almost all the points here. And I discussed almost all these points in my channel. I talked about them in different videos. I said, guys, hold on. Hold your horses, as the Americans say. Hold your horses. Scaling with common sense. So I'll leave the article below for you guys to read. The gist and the summary of this article is, guys, the old ways of scaling are not dead yet. Microservices horizontal scaling is good, but before you jump into that, realize the cost, realize the expense of maintaining that thing. Don't jump into this because it's fancy, because it's sexy, because it's just what everybody's doing. That doesn't mean that you're using this technology. That means you're modern, right? That's what people like to say. Oh, this is the modern way of doing things. No. If it scales, who cares? I like that. That rhymed. All right, guys, let's just jump into all the points. There are around, 14, 15, 16 points. We're going to go through one by one, and you can use the YouTube chapters to jump into the one you're interested in, because I'll just divide them into chapters. You can jump into this. So the first thing we're going to jump into that point is, and I'm going to just read the first title and then comment on that. Feel free to actually read the interesting topic in details if you want to, but I'm gonna obviously comment and critique the article on my way and how I understood it. So the first thing it says, comparisons are almost always meaningless. I could not agree with that. So it says, 1,000 requests per second on static data is not the same as 1,000 requests per second on an API that does a query on the database, or 1,000 requests that is a WebSocket connection, or 1,000 requests that does a gRPC, or 1,000 requests that does Vulkan, REST API, GraphQL. Those are totally, so the metric using request is incomplete. It does not mean if your API serves 1,000 requests per second and my API serves 1,000 requests per second, that is not an equivalent thing. So I cannot compare. If you can serve 1,000,000 requests per second serving an HTML file, and I can serve 1,000 requests serving a sophisticated query that is synchronous. That takes a long time. Not only just a query, a transaction that starts and then queries multiple tables and does some more processing. It's a long-running transaction. And then what does that mean if I use a message queue and I do this asynchronously? I can do millions of those requests, but I will get served immediately on those requests because they are just getting queued, right? But are they actually No, they are not. So comparison are really, really meaningless. So that's the first thing. So the topic of this channel is just like, okay, should we use microservices or not? But this is not only, he's talking about in general, right? Think before moving to a new technology, right? So that's the first thing he is discussing. And this is a very interesting point. Whether is in tutorials an article that demonstrates great scale under narrow constraint, how we open 10 million concurrent WebSockets with a potato battery. All right, he's going a little bit over the board there, but yeah, while transmitting zero data, while are good to satisfy academic curiosity, should not be treated as general purpose user manual. I could not agree more. Theory versus practical is completely different, right? That's the part. That's what we try to bridge, right? The people who study, obviously, they give us a great input to for innovation, but it doesn't always scale in practical when you try to implement it. Point number 2, scaling starts with well-built software. So he's talking about a poorly written Python web service may be able to handle 1,000 requests per second using $100 worth of resources, compute power, commodity software, right? While a well-written one might be able to handle the same rate with a 25 worth of resources. Scaling starts bottom up with a good code and good software. One moves on to scaling resources horizontally or vertically. I'm going to talk about that. We talked about that actually in this channel. After exhausting all easy optimization application code. Boy, I agree with this. So here's the thing, guys. You see that, oh, that's the problem we're making all the time. I see that my my application, my API, my backend only serves 1,000 requests per second, right? That means like one request is like what? Almost a millisecond, right? In this case, if I do the math right. So can I actually squeeze more requests per second on my application without doing any scaling? People will try to optimize or scale prematurely by saying, oh, this application just only does 3 requests per second, which is very, very obviously slow, right? That means, oh, let's just add more servers. Let's just add more applications, scale horizontally. So your application will now, okay, let's spend 3 instances, 3 requests. So that's 9 requests per second because you serve them in parallel. But you did not do the first thing you should do. Why your application is serving only 3 requests per second? Why is it taking so much time? So that's like what? 300 milliseconds per request. Yikesy. Can you speed that up? Can you squeeze as much performance as possible from the software? That's what he's talking about. Build well-written software. Sometimes you can't. Sometimes the nature of the request is long running. That's why the request will take much time. And now you can think, okay, should I make this request asynchronous? That's another thing. He didn't mention that, but just I'm adding value to this article, right? Should I move to an asynchronous system where let's just submit jobs and then worry about the response at the other time? Yeah, you're offloading the request execution to the backend, and you better have a good backend with message queues, whether Kafka, whether RabbitMQ, whether ZeroMQ, whether any message queue that kind of pick and execute this thing. Uber recently moved to this architecture, completely asynchronous, which is beautiful in their ordering payment system. I'm going to talk about that in another video. But this is very important, guys. Optimize your application as a singleton before moving to scaling. Just because your application is slow, you don't even have an index, and your query is slow because of that. We talked about indexing. Check out the video here. Eat healthy and exercise daily. I don't understand that one. So is the non-tech equivalent of premature optimization is bad. Okay, that's exactly what I said. Premature optimization is bad. Everyone has heard it. Appreciate it, but finds it difficult to practice. In the beginning, focus on writing good enough software, the refactor and improve as time progresses. Trying to build for web scale on day one can turn out to be painful, as the careful premature optimization gets thrown out of the window as the business and the user requirement change unpredictably. Because yeah, you want to ship, so you don't really care about optimization at that scale, right? Also, not every piece of all software has to be low latency and high throughput to begin with. on the other end of the spectrum is being lazy, ignoring common sense principle, leaving them alone. I didn't really understand what he's trying to say here, but essentially just premature optimization is bad. And what are we talking about is, I'm going to flip this a little bit to premature scaling, right? Because you can still do optimization at the application level, as he explained on point 2. Point 4, KISS, don't be afraid, and boring is greater than cool. that's very, very nice, right? That's a very nice point, because keep things simple. If you can work with VMs, definitely work with VMs. If you can work with physical machine, work with physical machine. And if you, back to point 2, where it's like, if your software is good, it's going to use the entire resources in an efficient manner. Okay, so it is absolutely fine to write a couple of bash script to rsync files to our remote servers to get something up and running. It does not have to be containerized and deployed on Kubernetes cluster on day 1. Oh my God, I can't agree with this more. That's the problem. Everybody want to automate everything. Everybody want to automate everything, and they don't have like to touch anything. We might get there after 20 years, guys, but I don't think we're there yet. Sometimes if you're building a small app, right, and a small architecture, a couple of bash script, just run a couple of bash script that does the job, and you schedule them with Windows tasks or with Linux tasks, cron jobs. That's the job. Keep it simple. Don't jump to Kubernetes and microservices just to do this one thing from day 1. A lot of people pushes microservices on day 1. I am totally against that. Totally against that. Unless you absolutely know that your application is gonna scale to the millions, to the billions of services like Google, then do it from day 1. But it's overkill. To me, it's just overkill. Keep it simple. Keep it simple. The bottleneck is almost always the database. Wow, this is so underrated. This is so underrated, man. This statement is so underrated. The bottleneck is almost always the database. So true. Because your request is going to fetch from disk at the end of the day, unless you're serving static files. But queries, databases, your request eventually is going to hit the database. And if your query is slow, then your entire pyramid will collapse, basically, because everything depends on that single query, right? So caching, proper indexing, proper partitioning if you want to. Sharding, I wouldn't go there unless you absolutely need that. But yeah, basic database. I'm gonna take this time to plug my course, Introduction to Database Engineering, where I teach you these things, the fundamentals, the first principles of the database. Talk about these stuff. What ACID? Talk about indexing, partitioning, sharding. When do we use when? I talk about protocols in the database, quick, and whether databases uses TCP today, but whether should we ever go there with pooling and quick and multiplex connections using HTTP2 or versus quick in the future. I talk about all that stuff in my course. Check it out. Go to HusseinNasser.com/courses. Yeah, RDBMS work almost always. Yeah, he's an old folk like me. I like RDBMS. A lot of people moves to the NoSQL. Yeah, nothing wrong with them, but believe me, RDBMS work. Relational databases still work. I agree. Everything can be reduced to CRUD, 97%, and he's coding that. It's not obviously correct, but yeah, represented as relational data that need ACID guarantees. You almost gonna need ACID guarantees. Almost. Very few problems need MapReduce or schemaless storage, right? I don't know about this statement. I mean, to me, all the problems I faced is filled into the 97%. I don't know if that's small. What does a small mean? Very few problems. What does that mean? I kind of have to disagree with that. We need someone who actually worked with problems that are absolutely cannot be solved with RDBMS, and you need schemaless storage, and you need NoSQL for that. So he goes through this in there. Everyone forgets to index. Well, I don't kind of agree with that. I think people are smart. They know about this. And they know about indexes. I mean, the first thing you spin up a database, you know when to index and what to index. I would qualify that statement with everyone actually over-index, maybe. Some people actually, like Uber, I believe, I keep forgetting. I think Uber moved from Postgres to MySQL. And I don't know why. They didn't specify exactly why. Their blog was very weird for that. But they moved from Postgres to MySQL. Again, I don't remember whether MySQL to Postgres or Postgres from I believe it's Postgres to MySQL. Because they over-indexed. They just indexed every column that they are actually querying. That was bad because, guys, indexing is not cheap. Yeah, it's great. My database is slow, but if you use explain, and we talked about all this in my course and many videos in my channel, you can explain and see where is the path of the query takes you. Is it doing a full table scan? And you can add an index, but adding too much indexes can actually slow down your writes because those indexes are cheap. Ain't cheap. You gotta maintain them. You gotta add them. It's not cheap. So yeah, everyone forget to index. I wouldn't agree with that. I think people are smart. I think people are index. I think people over index, if you ask me, and that's the problem. Or they don't know what to index, which could result on problems, right? Because the database, guys, let's go back. I need to talk more about this. The database not always uses the index, right? The database are smart. It's written in a specific. And some people are now introducing AI into the database planner to decide when to use the index versus when to do a sequential scan. Sometimes a sequential scan, if you're pulling a lot of rows, is way more effective than using an index because of the scattering. You gotta go in the index and go back to the disk and then go back to the index and go back to the pages, and you start. Yeah, this is gonna be a disaster in this case, the index. Sometimes the database pick sequential scan over indexing. Yeah, definitely. But yeah, look at this stuff, guys. So much stuff you can optimize without microservices, without horizontal scalability. Don't use an RDMS. What? Okay, this guy loves RDBMS too much. All right, so he says like, while RDBMS are great, bearing the dramatic effect of the title, as said earlier, they are almost always the cause of the bottlenecks in a typical database backend application than the application code itself. Isn't that the same point he discussed? I feel that he is repeating a little bit. So. All right, every individual query is a network round trip to the database that involves sending the query to the database planning and execution of the query, and sending the data back over the network if it's possible to combine multiple queries into a single. Okay. So he's talking about, yeah, you can still optimize the database itself. If you're sending multiple queries on the same, because it's a TCP connection between the client, which is in this case the backend application, and the database, you establish a TCP connection, right? And then you start sending the queries. If you can minimize the chattiness between the backend and the database as much as possible by sending less queries. So he's giving an example where you can use a CTE comment table expressions and joins and nesting. So throw this on the database and let it do the work and give you the result one, instead of doing a query and then getting back the result and then doing a query with the result from the first query and then joining it. You can do it client side. Sometimes it's more effective doing it this way, but sometimes it's effective doing join. I am afraid of using joins because joins are very slippery slope if you don't know what the database is gonna do at the back end, right? Is it gonna scan? Is it gonna use the index? Sometimes it gets really nasty really quick. It gets so we try to avoid join as much as possible. Sometimes it's not possible, but yeah, that I agree with this. If you can minimize the number of queries, do. If not, then you have to do it this way. 9, networking I/O is really hard. Network as little as possible. Yeah, this is exactly the same point. He's repeating himself a little bit, but I like that. I like that. So chattiness, guys. So we have a database and we have the client, which is the backend application. And if a TCP, guys, is very expensive, we talked about that, right? Check out the three-way handshake. Establish the TCP connection, three-way handshake, and then every query you send comes back with an acknowledgement, and then you have to make sure that you actually respond. And there is so much going on there. So if you can send one request and try to shove everything you want in that request, that will be amazing. But sometimes it's not possible. That's why I keep talking about this concept. Check out this video where I coined this. I believe nobody actually did this for. Keep your servers closed and your database closer. I made up this, and I talked about it many times on my channel. Check out the video here. So you have to keep your servers close to your application client and keep your database even closer. You have to keep the database very close to the backend application as much as possible so that you minimize this latency, this acknowledgement, these three-way handshakes. You have to, if you can, preheat this TCP connection, preheat them, use pooling as much as possible. I talked about pooling, guys. Check out the video here. So this is so funny. I talk about something and he just mentions it in the next point. So 9.1, connect little pool much. So he's doing the pooling, which I just literally discussed in this case, right? Pooling, guys, if you don't know, just start the application and open 7, 10, 100 TCP connection, preheat them. And then when request comes, you can use any TCP connection to execute the request, right? And then it doesn't matter because they all gonna connect to the same database, right? So that has been solved with HTTP2, right? And I'm pushing someone to use multiplexing with databases, right? I didn't see any project that does this today. But the problem with pooling is very resource intensive. Yeah, it's very great. Also, I don't have to use the same connection to send the same query over and over and multiple queries on the same TCP connection because it's a big deal. We talked about it, right? That's a big problem. Don't use one TCP connection and send multiple queries on the same TCP connection. The database have no idea which query belongs to which response belongs to which query. So you might get very bad results. That's why you use pooling. And now the best thing is we have the same problem with the browsers. The browsers have the same problem. They send multiple requests to the same host. HTTP, you're pulling this page and there's like 1,000 CSS file, a little bit exaggerating, and 3JS JavaScript file and 700 images. How do you request all of them? You have to open multiple TCP connection, HTTP 1.1, and then start sending as much in parallel as possible. And the goal is you can only send one request per TCP connection. Minus pipelining. I don't want to talk about that because that's a bad idea. But yeah, that's the idea. So you can send as many as possible, but you're still blocked, right, with this number of TCP connection in the browser. So the browser did is that they invented HTTP2, which is allow you to use one TCP connection and kind of coat your request with headers that lets you know, oh, this request belongs to this request. There's a stream ID with every request. It goes so you know, right? So you can multiplex multiple requests in that same TCP connection. Beautiful design. We need to bring this to the databases. I don't know why nobody's talking about this. We need some database to support. I'm not going to say HTTP2 because it has its own problem, and database people don't like HTTP because it's a what's the word they use? It's bloated with headers and stuff. Fine, use Quick. Now, the problem with UDP and blocking, I don't think it's a problem, to be honest, because databases are usually in an internal network and UDP will be allowed. So you're fine. We need a database that support Quick. Please, someone build that database that supports Quick so that our backend application can create a beautiful single connection and then multiplex shy on this single TCP connection, on the single connection. Pooling. Latency is the metric. I agree. If I can send a request and I get the lowest latency the possible, that's the best thing. And latency translates to many things, right? And doesn't mean like how long should it take to actually open the connection and establish the request, pack the request into this connection and send it, and then execute the request on the back end. That gives me the question, what is really a request? A very, very philosophical question. I talked about it right here. What is a request? What's a request exactly, guys? What is a request? Because if you think about it, like, it could be, which layer are you? Are you on layer 7 talking about request? Are you on layer 2 talking about request? That's a frame. On layer 3, that's just an IP packet. On layer 4, that's a TCP packet. On layer 7, that's an HTTP packet, for example, request, if you was using HTTP, right? Or using the protocol that is built on top of whatever protocol you use, right? Database, Postgres uses their own protocol. Redis uses their own RESP protocol, whatever. The internet is a wild, wild west. Imagine a well-built, highly optimized, low latency service with high throughput that handles 100,000 requests a second. Ooh. 1 million concurrent users start sending requests to it, widely varying, right? From varying 3G, 4G, and broadband network over HTTP connection. The service will instantly respond to an incoming request on a connection, but the connection to the user over the internet is unpredictable. It may take 50 milliseconds or several seconds to write a response. That's the server writing the response, right? For this period, and when you see writing the response, that's just I can talk about this for 30 minutes. Writing the response is just writing the packets in TCP and getting acknowledgement for each packet, right? So that's what he means by writing a response. The full response is going to be a layer 7 response, but at the packet level, it's going to break down into multiple packets, and each packet needs to be acknowledged and ordered and garbage, so much stuff. For this period, the connection is held hostage by the user's poor network, and it's happy. That's true, because if I can't get acknowledgement on my beautiful small packets, I cannot send the response, and I'm holding the connection hostage and resources, precious server resources, hostage. That's how slow loris attack works. If you have never heard about it, slow loris is an attack that uses a slow network to simulate a slow network on a server, on a client, so the server can actually spends up a lot of resources on this. So yeah, it says typical just deploy HA proxy, Nginx. We talked about all these in my channel. Deploy a load balancer, detect all this stuff. Most of the stuff, Cloudflare have services to detect this. Layer 7 proxying, layer 7 reverse proxying can actually detect this thing and kind of what's the word? Shift the load onto something else, and instead of your backend servers, shift the load to the load balancer. And then Nginx and HA proxy are built to deal with these things. Caching is silver bullet. Ooh, caching is great. Since RDBMS queries are expensive, add layers of caching. Again, I don't know what he says exactly here, but I would only add a cache if you absolutely need it, because cache maintenance is hard, man. It's very hard. And he talked about the dump caching is the best caching. When a request looks up data in the cache and dumps it directly in the response, that's a dump cache. The cache logic has no understanding of the semantic structure of the data stored and just does byte out. Dump caches are nice, and the application needs concern about parsing the data. But again, you only need to, how do you trust the cache? That's the bigger problem. That's why we have write back cache and then write through cache, and then how do you invalidate the cache? One computer science professor, I forgot his name, he says the hardest problem in computer science is cache invalidation, and I can't agree with that more. Some application state might not be bad. So yeah, I used to be I used to be against this. I used to be the kind of guy where, oh, stateless is the way, always be stateless. But I changed with the years as I grow. I think stateful application are needed. Sometimes you need your application to be stateful. I actually ran into it when I built a game with WebSockets. What I needed my players of that particular game to be in the same server, and that's stateful, right? And instead of having a third layer that maintains a cache and have my application statelessly query for the game state, I put all of them in one server, and that's challenging to build with WebSockets. I actually couldn't build that. I had to write. I didn't do it yet, but I have something in mind to have the layer 7 proxy actually terminate the connection and then have a knowledge of the content in order to do this. I don't think you can do it with WebSockets. I might be able to do it with long polling, for example. So I'm still thinking about that. So might actually change my design to a stateful design, because yeah, stateful is great, because if I have my memory data locality, my cache is in beautiful same place. That's the best thing a backend engineer can ask for. HTTP APIs can be e-tagged. 304 too. Oh yeah, this is underrated, man. E-tags are so underrated, to be honest. I don't know if he agrees or disagrees with this, right? I like e-tags. If you know what you're doing, if you built e-tags yourself, if you actually generated the e-tag, the browsers can help you so much. But it's a double-edged sword. If you don't do it right, you can serve your users with bad old stale cache data. I talk about e-tag, guys. Check out the video here. This is not widely as is surprising to me. Client-side HTTP caching is what underpins the large scaling content delivery. Yeah, it's just with static data, you're good with e-tags. It just takes care of things. The browser caches, store the hash in e-tag, check the server if the file has changed by sending the e-tag. If it hasn't, the server responds with 304. Okay, we know how e-tags work. They work beautifully HTTP APIs too. And we know that 97.42 all API in the world are HTTP JSON. Return the JSON response, uses the reference, and if the response hasn't changed, why send the response all over again? Nice. We send an e-tag with all HTTP requests. Kite. I don't know, Kite is the software that uses. This is a little bit, I don't know what he's trying to say with this, but e-tags are great, guys, but I have no idea how we're going to effectively build your e-tag in a database query, because the act of checking for an e-tag require a query to the database, and you need to maintain the state. So you might need to maybe I do a get, right, and I receive an order, and I then query the database for the orders, and then I respond, and I generate a unique hash for the orders, and I respond back. So now if the user sends me the same e-tag, how do I know to actually respond back with that same, say, hey, this didn't change? How do I know that e-tag is already generated? I have to query the database, right, to check if it exists or not. You can avoid that by generating your own table with an e-tag and like some sort of a flag that tells you if the order has changed or not, and accordingly respond, right? But that kind of just destroys the concept of HTTP semantics with GET, because in this case, when you do a GET, you're gonna actually write, where GET is actually a safe method. You might get away with it, but it's not easy to implement, in my opinion. Allocation is expensive, memory allocation. So he's talking here about garbage collection data. I agree with that. It really depends, to be honest. I think he's over exaggerating this on it. Yeah, I agree with some of his points. I don't agree with everything. So this is a little bit exaggerated to me. If your service is the bottleneck and it is receiving thousands and thousands and thousands of requests per second, then I agree. The GC languages, garbage collected languages, can pose Your application can pause your request and slow down your queries as a result. Meet Linkerd. Linkerd is a sidecar proxy. They built their sidecar proxy using Java. And Java, you know Java, guys. It's a garbage collector language. And the JVM machine has like 100 megs or something like that. It's very big. So after they scaled, they noticed that there are these pauses that just freezes the application, and request cannot be met. So their tail latencies are just shot, and it's very slow. So they moved their proxy from Java to Rust. Rust is not a garbage collector languages, huh? So they brought, I think, their runtime size to 1 megabyte, I believe. It's nuts, man. But that's only for them. So what's your name? I forgot your name. So Kalish here is contradicting himself, to be honest, because he's saying, oh, don't use garbage collected languages, right, because they are expensive. At least that's what I thought he said, right? But he's in the same times like, yeah, use other language. But this is, to me, this is premature optimization. Unless this is what he says, right? I don't know. Memory allocation is expensive, especially in GC. We write our high throughput services in Go. Simple to learn, highly productive, which is in GC language. Thanks to our services mostly being I/O and not heavy in memory. That's true. Because if it's in memory, then you're gonna start feeling the garbage collector. He's right. We are unlikely to run into any garbage, but there are common sense principles that we use when writing Go. There are applicable to other languages as well. On hot path, allocate as little as possible, reuse buffers, try to avoid. Okay, I'm sorry. So he's not telling you to not use garbage collection language. He's telling you to be aware of this, because allocation is expensive. So try to not allocate memory unless you absolutely need it. I apologize. Okay, it makes sense. But think about that. Sometimes you need to switch your programming languages because you need to write a lot to memory. So garbage collection could be a problem, and the GC pauses can be hurtful. So you might want to switch language in that case. But most of the time, if you're doing what he's asking for, which is a beautiful point. Thank you so much. This is good. I like it. Multi-threading and concurrency are necessary but hard. Oh my God, he's reading my mind. I talked about this right here. Check out the multi-threading. When it comes to me, I try to use a single thread application as much as possible, and try, if possible, squeeze everything out of it, because it's way easier. Concurrency are great. Multi-threading is great. I mean, most proxies are multi-threaded, but it's so goddamn difficult to build, right? I know Go has their own now multi-threading system that makes it easier, but what if you want to access the same resource? It's complex. So I talked about that. So I'm not going to spend more time on talking about this. Some technologies are generally slow. Use fast technologies. Python is slow. Ruby is slow. Frameworks like Aurora are slow. Yeah. Here's my point. Comment on this. You can use technologies as long as you know how they work. Do not use stuff that as a black box. I am completely against this. If you use Ruby and you know it's slow and you know how to work against it, by all means. However, if you use a technology, a lot of people use React blindly. They don't know how React works, and they complain about the performance later because you don't know how it works. So you're using it for a different task than it was intended to be, right? So these are very, very critical points to understand. WebSockets. A lot of people use Socket.io instead of WebSockets, and they complain about some bloat that Socket.io have. Same thing. Some technologies are slow, so I have to agree with this. You have to know what to use and what not to use. Scale horizontally, vertically, and enterprisingly. I like this point a lot. Scaling vertically is so underrated. A lot of people just say, oh, let's just scale horizontally. Try sometimes scaling vertically, because it's way cheaper sometimes to scale vertically. Cheaper in terms of, yeah, you're gonna pay more money, but it's gonna take less maintenance in the future, because, and he said it very nicely, so scaling horizontally is complex, because the moment you scale horizontally, you need a load balancer, you need a reverse proxy, you need to maintain a reverse proxy, you need to teach the reverse proxy. The reverse proxy becomes the bottleneck in this case, because it's routing request, and now you have to scale the reverse proxy by adding a DNS router on top of that. So you can get very scaling, premature scaling very, very quickly, especially with a container. They're so easy to scale, that so that Kubernetes get added on top. I'm gonna add my 2 cents of Kubernetes at the end. Human impediment, yeah. Sometimes, often, a managerial bottleneck is a bigger impediment to common sense scaling than a network I/O. So yeah, essentially, he's talking about a lead who pushes a distributed NoSQL database where an SQLite file is sufficient, or a service mesh microservices instead of couple of processes behind. Oh my God, I can't agree with you more, my friend. That's the problem. So if you get some CTOs, right, or just some leads that says, hey, there's this shiny beautiful thing that's called NoSQL. And it scales. It's built for scale. Let's just scale, distributed, and all that stuff. Where your problem can be solved with a SQLite file. Your problem can be solved with a simple Nginx. Your problem can be solved with HA proxy, with Envoy, and you just adding this garbage. You add services and make microservices, and or a computer, or you can just spin up an EC2 instance and solve it. My thought, guys, my final closing thoughts about this, and this is gonna get a little bit conspiracy theory. That's just my conspiracy theory voodoo hat, I think. And the whole thing is just my opinion, and it's all allegedly, all right? It's just all me. Think about this. Here's what I think people moving to Kubernetes and microservices. Here's what I think why. AWS started the cloud era. Amazon. They took most of the customers. Everybody's in AWS. Everybody's in the cloud. It was a smart move from Amazon. So everybody's in the AWS services. All their money, most of their money is coming from that. There's so much, tons of money. So now Google comes in and wants to dominate the market, and Microsoft comes in to dominate the market. It can't. It's just, the market is just saturated by the AWS. So what should it do? Let's invent this idea of cloud lifting and locking, which are not essentially incorrect problems. They are real problems where you're locked into AWS. Is that a serious problem? I don't know. It depends on you. I'm not on the cloud, but if you built an application and you spins it up on AWS, you're using AWS Lambda. You're using these technology. You're using EC2. You're stuck to these technologies. That might be a bad thing or might be a good thing, but I think Google just blown it over the top. It says, you're stuck to this. Let's move to this idea of Kubernetes. What is this? Oh, it's just like the operating system of the cloud. You install Kubernetes, and then you spin up your containers, and then that's it. It's just a PaaS. It's a platform. It's a platform as a service. So you take that soft Kubernetes. If your application is on top of Kubernetes and these containers are talking to each other, you just lift and shift to another cloud provider. So the container orchestration wars started in 2016, I believe, 2015. And Google clearly won this war with Kubernetes. Why? Because containers were born, application deployment became so easy that people got so greedy, spending multiple of them. Managing container became so hard. You need something to orchestrate the containers. So we built Kubernetes, and now Google advertises Kubernetes like there is no tomorrow, just so that everybody moves from AWS to Kubernetes, so that Kubernetes is actually literally a ship that is designed to take the money from AWS and just ships away. Google doesn't want to take that money. It doesn't have to be. It's just the idea is like, how do I move people from AWS? Kubernetes is the solution. Again, that's just my conspiracy theory hat. I'm wearing it. But I think that's what's going on, because it's crazy what we're doing, guys. It's crazy. Why is Mike's donuts shop moving to Kubernetes? That's just nuts. It's a donut shop. It's a garage. Why do you need Kubernetes? Why do you need containers, for God's sake? You don't need any of that stuff. Spin up a VM and that's it. You don't even need to horizontally scale. Why? We're over-engineering, guys. We're over-engineering. We're over-killing ourselves with this stuff. But that's my thoughts, guys. What do you guys think? Let me know in the comment section below. I'm going to see you on the next one. Sorry for the long video, but I had so much to talk about in this video. Agree. Whether you agree or disagree, like this video or dislike it, right? And let me know your comment section, your opinion in the comment section below. I'm going to see you on the next one. You guys stay awesome. Goodbye.